everyone, this is Mr. M from Algebra Lessons. In this video, I am explaining multiplicative inverse of a complex number. Like real numbers or regular numbers, the complex numbers also have the inverse for multiplication. Okay, so we can use some examples to make it more concrete. So z equal to a plus ib is a complex number, and as we know, multiplicative inverse property is this: if x is a number and x inverse is its multiplicative inverse, then the product of these two should provide us the multiplicative identity. So this idea you should need before you approach this concept of multiplicative inverse of a complex number. So we have a complex number z equal to a plus b, and I'm assuming another complex number c inverse. Okay, this is inverse, not consider this as an exponent. This is the notation to represent the inverse. Okay, that is actually 1 by z. Okay, so z inverse is equal to, we are assuming z inverse is another complex number with u plus iv. So a plus ib is z, and z inverse is u plus iv. So as per the rule, as per the inverse identity rule, when we are multiplying these two, let me try with a different color. When we are multiplying these two, z times c inverse, that is equal to a plus ib times u plus iv. Okay, a plus iv times u plus iv. So when you are combining and arranging this, your brackets will be combined in this form: au minus bv plus av plus bu of I. So this is actually the expanded form. And if this z inverse is actually the multiplicative inverse of this, then the product should be is equal to 1. So this is equal to 1. That is au minus bv plus I into av plus bu is equal to 1. Okay, so I can rewrite this in the form of a complex number 0i. That means these two complex numbers are same, means real part should be same and imaginary part should be equal. So here the real part is au minus bv. Here the real part is 1, so we can equate those two. Au minus bv equal to 1, and av plus bu, sorry, that is bu, av plus bu equal to 0. Okay, so when we are solving these two equations for the unknowns u and v, when you are solving these two equations for the unknown u and v, I believe you know why we are solving these equations for u and v, because this is just an assumption. The second complex number is just an assumption. We have our original complex number or the parent complex number, that is a plus ib. So we actually don't need to find the value of a and b, because that's actually not unknown. we are actually trying to find out these unknowns u and v. So because we are assuming that u plus iv is the conjugate. Okay, so we need to solve this linear system for the unknowns u and v. So when you are solving that, you will get u as u is equal to a over a square plus b square, and v equals minus b over a square plus b square. So this is the very important information you should have when you are approaching a complex number problem, inverse problem. Okay, so if z equal to a plus ib is a complex number, and if you need to find out its inverse, its multiplicative inverse, you need to choose another complex number in the form of u plus iv, where u is equal to a over a square plus b square, and v is equal to negative b over a square plus b square. So from the first that means the parent complex number, from the parent complex number itself you can easily find out the inverse complex number by using this equation. Okay, let me show you one example. Okay, okay, so we can try divide 6 plus 3i over 10 plus 8i. Okay, divide 6 plus 3i over 10 plus 8i. So we are approaching this problem with the concept of inverse. Okay, so rewriting this, I'm trying to rewrite this problem. Okay, 6 plus 3i over 10 plus 8i can be rewrite as 6 plus 3i times 10 plus 8i to the power negative 1. So the rule what I used here is x by y is equal to x times y to the power negative 1. This is the rule that I used here. So, and see, now this is in the form of z times z inverse. So what is our objective? Our objective is to find the inverse of this particular complex number. So we can try. How can we find the inverse of this particular complex number? 10 plus 8i the whole to the power negative 1. We need this is actually the parent complex number. So z equal to this. We need to find out a z inverse. So there, if you are considering the z inverses in the form of u plus iv, what is u and what is v? We know from this result box. U is a by a square plus b square. So a over a square plus b square, and v is negative b over a square plus b square. So this is equal to a. What is a in this parent complex number? That is 10. 10 over a square plus b square. A is 10, so 10 square plus b square. B square is 8 square. That is 10 over 100 plus 64. That is 10 over 164. So this is the value of u. And what is v? V is minus b over b is 8, so minus b, that is negative b is negative 8 over a square plus b square. A square plus b square already calculated, that is 164. So negative 8 over 164. Okay, you can simplify if you need. So I'm going to rewrite, I'm going to take this inverse thing here. So this will be continuing this portion. That will be 6 plus 6 plus 3i times inverse of this, that is this is a u, this is in the form of u plus iv. U is 10 by 164, 10 over 164 plus I times v is negative 8 over 164. Okay, just rewrite it. 6 plus 3i times, 6 plus 3i times 10 over 164 minus I times, because this minus I took here, minus I times 8 over 164. Okay, so that is actually the answer, but we need actually a simplified form. So simplify it, and then the answer will be 6 plus 3i times, you just rewrite this as 10 minus 8i over 164, because both of them have the same same denominator. So then putting over 1, that is 6 plus 3i times 10 minus 8i over 164. When you FOIL this bracket, what will be the answer is, it is 60 minus 48i plus 30i minus 24i square over 164. So when you simplify this, your final answer will be 21 by 41 minus 9 by 82i. So this is your final answer for the said problem. So our question was this: what is, or divide 6 plus 3i over 10 plus 8i. So our answer is 21 by 41 minus 9 by 82i. So this is the way we can use our concept of inverses in this particular type of problems. I hope everyone is enjoyed this video, and if you really wish to get more videos of the same kind or the topic that you may like to watch, please subscribe this channel, and please try to like, share and subscribe this channel. Thank you.